Hello guys, welcome to my YouTube channel Concept Clearance. As this is a computer science major show, so in our very first video, we will discuss about the topic that logic and proof. So now, when we talk about the word logic, the very first word that's struck in our mind that what is logic? Logic is nothing but only a base of all the mathematical reasoning and automated reasoning. Logic is a simple mathematical statement that specifies a reasoning. Next term is preposition. It's a declarative sentence which can either be true and either be false. It is declared the true statement which is denoted by the capital T and the false statement is denoted by the capital F. Next term is compound preposition. Compound preposition is a sum of preposition plus any operator. And what is the operator? We will talk and discuss this in further. First, what is operator? There are three kinds of operator. The first is negation, second conjunction, and the third is disjunction. The negation operator is denoted by this symbol. Suppose that P is any statement. The negation of the P statement will be this. And there are two statements such as P and Q. The conjunction of these statements will be like this, P and Q. And the disjunction of the P and Q statement will be this. These are the symbols which denoted these operators. First of all, we will talk about the negation statement. First, suppose that if a P statement, which is today is Sunday, and the negation of this statement is today is not a Sunday, or you may talk like that it is not the case that today is Sunday. If you talk about its truth table, that suppose it's a P statement and the negation of P, it's a true, then it will be false. If it's false, that it will be true. Next is conjunction statement. As I am led that you are a computer science student, so you will very well know about that not, and, or operators. Negation was not operator, and the conjunction operator is as and operator. So if we talk about its truth table, that suppose there is a statement P and another statement Q, the conjunction will be P, Q, and suppose there is a statement true, true, it will be true, it's true, false, and it will false, the false, true, it will false, 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 and false. As there are written statements, so there is not any proof that Y, T equals to T, T, F equals to F. You have to just memorize it. Okay, and so now our next operator will be disjunction operator. Disjunction operator, it is same as the or operator, which I will talk about earlier. It's denoted by this symbol. So if you talk about its truth table, then suppose there is statement P and another statement Q, and then P disjunction Q will be, it is statement true, it will true, and this is also true. If this true is false, then it will true. If this is false, this is true, this is true. If it is true, it's true, and it will be always false. Mostly a question that many times had been asked, whether you are from college guy and a school student, that to construct a truth table is like this: negation of the statement and conjunction of negation of Q. So how you will make its truth table? So it's very simple. Suppose there is statement P, Q, it says true, it says true, this is true, this is false, this is false, this is true, it's true, and this is false. The negation of Q will be false, true, false, true. And P disjunction negation of Q will be true, true, false, and true. And the negation of this statement will be like this. it will be false, false, true, and false. So now next our topic is biconditional statement, which is denoted by, suppose there are two statements P and Q. The biconditional statements are denoted by this sign, or many other authors are denoted this, like this. Okay, so biconditional statements are the true when P and Q have the same both values and false otherwise. There are some common ways to express the biconditional statement. The first is P if and only if Q. Second is P if necessary and sufficient for Q. And the third is if P then Q. You may take example that there is a statement P like this: you can't take the flight. And there is a statement, another statement Q, that you buy a ticket. And the biconditional statement of P and Q will be you can take the flight. And now I will use this statement P only if and only if Q. So now this is statement P, and I will use this statement if and only if you buy a ticket. So now let's take a look. P is a statement you can take the flight. Q is a statement that you buy a ticket. So now biconditional statement of P and Q will be you can take the flight if and only if you buy a ticket. You may also like this, you can take the flight if necessary and sufficient if you buy a ticket. Okay. Our next statement will be condition statements, which is denoted by this symbol. Okay, which means that this whole statement will be false when the P is true and Q is false and truth otherwise. Listen carefully what I'm talking to you. This whole statement will be false when P is true and Q is false, where P is a hypothesis and Q is a conclusion. Okay, so now if we talk about its truth table, then it will be, suppose there is a statement P and a statement Q, and the Q condition Q will be it's a true, it's a true, it's true, it's true, it's false, it's false, it's false, it's true, it's true, it's false and true. Now you will be just to behave that how it comes. So now just remember what I have talked earlier. The whole statement will be false when P is true and Q is false, and it will be true otherwise. Okay, so now just some of the whole concept that we studied earlier by the means of truth table. Suppose that if there's a question like P condition Q bicondition, the negation of Q and the disjunction of negation of P and Q, and then how you will be construct its truth table. It's very simple. There's a statement P and there's a statement Q. It's true, it's true, it's true, it's false, it's false, it's true, and it's false, it's also false. The negation of P will be false, false, true, and true. The condition statement of P and Q will be true, false, true, and true. The negation of this statement P disjunction Q will be true, false, true, and true. So now what we want is to find out this statement. and now it will be true, 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 true. Okay. Further, we will elaborate more the conditional statement. There are three types of conditional statement. The first one is converse, second is inverse, third one is contrapositive. Okay, suppose there is a statement that P condition Q. So how will we differentiate this statement in this two? Because these three all the parts of conditional statement, where P is a hypothesis and Q is a conclusion. The first one will be written as Q by condition towards P, and inverse will be written as negation of P condition towards negation of Q. The contrapositive will be written as negation of Q condition towards the negation of P. If we take an example, suppose if I take an example that if it rains today, its whole is a P statement, and another is I will go to college tomorrow. It's a Q statement. So now how will you written this statement in a converse? It's very simple. You will be written this, that I will go to college tomorrow only if it rains today. I've written like it is tomorrow there. Okay, so now this is statement P. If it's rain today, and Q will be I will go to college tomorrow. So now you will written converse like by putting the Q statement like this before the P statement. I will go to college just like Q tomorrow only if it rains today. Okay, and its inverse statement will be like this. If it doesn't rain today, then I will not go to college. And the contrapositive will be if I do not go to college tomorrow, then it will not have rain today. Okay, so now these are the topics of condition statement. These are the parts of condition statement, which is converse, inverse, and contrapositive. Our last topic is equivalence relation. If you want to show the two statement equivalence, such that will be A statement and B statement, then you will be show them like A this, and some different authors use this symbol to show the equivalency of two statements. So now suppose that if it's a question like P disjunction of negation of Q equivalence of this. So now how you will be show that these are the equivalent. So now you just only construct a truth table, which is suppose there is statement P and Q. It's true, it's true, it's true, it's false, it's false, it's true, it's false, and it's false. The negation of P will be false, false, true, true. The negation of Q will be false, true, false, true. The P disjunction of negation of P will be true, 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 and the Q disjunction negation of Q will be true, 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 true. As you see that these statements are both equivalent. So now hence it's proof that these are the equivalent statements. Okay, thank you. In our next part of this topic, logic and proofs, we will talk about how to prove the statement by implication and theory of inference. I hope you guys like this video too. uh, don't forget to like, share, and comment and subscribe, because sharing is caring after all. Thank you so much, guys.